Hi, good day everybody. Today's topic of discussion is use of smart device in civil and geotechnical works for vibration, noise, and temperature measurement. Two areas of study were recently completed, one by Arab and the other by the PolyU. These studies were supported and funded by the CIC. The role of CIC is to drive for excellency of the construction industry in Hong Kong, as well as we also would like to encourage and facilitate research activities and use of innovative techniques for the construction industry as one of the many functions. So how can this be achieved? So we will engage consultants, academic institutions, and in-house resources to carry out study and research work and real practical problems in response to the needs of the construction industry. The recent work that were completed recently were by Arab on the development of an app for iPhones for real-time monitoring and assessment of construction-induced vibration and noise, and the other one by Arab on the application of maturity method for estimation of concrete strength in concrete structures.
As we all know, now we are in the era of smartphone. We are using smartphone everywhere, all the time. The motivation of our research project is very simple. We think about, can Hong Kong construction industry benefit from the rapid development of smartphone? That's why we developed this app to help the monitoring of construction-induced vibration and noise on construction sites. This is the flowchart of the app development. We first come up with this idea, then we did some coding using Xcode, then developed some database in Firebase. Then we designed and developed this graphic user interface. Finally, in the middle of last year, we released this beta version and let different users to try this app. In addition to this software development, we conducted a lot of laboratory tests to calibrate sensor sensitivity. We can see some photos of the laboratory experiments here. We can also see the comparison in the time domain and in the frequency domain. After the laboratory calibration, we conducted a series of field measurements on construction sites. Totally, we conducted field measurements on 8 different construction sites with different construction activities. For example, sheet piling, mini piling, bore piling, rock excavation, and concrete breaking. Here we can see the video of the sheet piling measurement. We conducted the measurement using iPhone and using traditional vibrograph. Then we did the comparison. Meanwhile, we also measured the noise using this smartphone and compared the noise measurement with the traditional noise meter.
Hi everybody, my name is Goman Ho from Arab. Today I'm going to share with you using the maturity method to estimate the early strain of concrete. For this graph, you see A, B, C, D. We need to find a relationship between from the temperature against time to strain against time. But through this process, we need another procedure to do it. One is from temperature to time, and then maturity to time, and then strain to maturity, at the end to strain against time. That means A, B, C, and D. Now, the procedure is we measure the temperature, and then we calculate the area under the curve, and then we find the maturity index. And then also similarly, and then we find the strain against maturity and also the strain against time. So we repeat this procedure, and then we will get the relationship between the temperature against time to strain against time. Then we get the how the strain of concrete could be gained against time. Now, so this is the A, B, C, and D method, right? And to do this, we need to also lead a procedure called calibration. We need to, based on the same mix of concrete, we need to do a bit of test before we apply the in situ test. And then we calculate the relationship for the maturity index against strain, and then we can find from A to D on site. Now, so this is what we call the P-calibration, right? From A to D, we need C to B. Using the maturity theory, we need to know how we can apply it on site. But it's relatively easy, and we use the IoT technique. And what we need is to provide a thermal sensor in an in situ concrete. And then through this thermal sensor, we measure the temperature against time. Through what we call a transmitter, or we call the data logger. And then from this logger or transmitter, we can be transferred to the cloud. And then from the cloud, we can download it to an app. And then through the app, we carry out the ABCD procedure from the temperature to time to, at the end, we can get the string against time. Now, this is pretty easy now because we have a lot of these tailor-made apps from various thermal sensor supplier. Right? And so here is actually a test by using different kind of sensor, and also the red dot is the in situ TMC measurement. And then you see that they are pretty accurate, and the prediction of concrete string are in good order, sufficient for our application.
This concludes our GED talk. Thank you.